This is Astronomy Daily Live. Hey, everybody. What's up? What's up? How's everything going? Hope everything's well out in your universe. Everything's good. Pretty good here. Pretty good here. Just got in from a few errands a little while ago. So, uh, not necessarily rushing. Got here pretty much just in time. Just had to vector in, just shoot right in. Hey there, Bobby. Nice to see you in the chat. Uncle Bill, thanks for coming in. Lifetime supporter, pretty much lifetime. Yeah, I think Uncle Bill, you probably came in. I don't know. I'm pretty sure you came in on the first week at least and have been there ever since. So greatly appreciated. I know that you're a supporter of all things science and nerddom. So greatly appreciate everything that you've done and continue to do. Hang in there, hang in there. I think we're having fun. I think so. I think so. That's the primary purpose of this live stream is have fun, and um, share a passion for the science of astronomy, and you know, we're going along this path together, right? I'm not up here on some kind of a soapbox with all kinds of titles and designations and everything, and and uh, um, and trying to give you answers and trying to explain how things are. I'm as confused as everybody else, but I'm also in absolute awe. So yeah, when I was very young, um, pretty much everything amazed me. Um, I wouldn't have been able to articulate it that way, but yeah, I mean um, everything I encountered, even really young, I was like, wow, that's pretty amazing, right? Hey there, Totterbert. Nice to see you in the chat. Um, so at a very young age, I uh, I was like, what? And I wasn't thinking of it in terms of like a profession or a livelihood or anything, right? I mean, I was 4, 5, 6 years old. Um, I'm like, how can I how can I find out more about everything? How can I do that? And I have absolutely no recollection of like the first astronomy book I ever saw at all. But my earliest recollection of this passion, which I continue to this day, right? To this day. Hey there, Tom. Um, I felt first, actually in the first grade. Was it the first grade or the second grade? I forget. But I wrote some, and for a 6 year old or a 7 year old, it's like I was like Shakespeare, right? I mean, just the most amazing prose, right? So I'm sure it was pretty terrible, right? But I wrote a paper uh, proving proving that there was life on Venus, and um, I don't remember exactly how I did that, but I remember feeling that passion sort of for the first time. Um, I found something. Hey there, Andy. Nice to see you. Come on in. Come on in. Join the circle. We're out on the virtual porch, right? And the sun is setting here, and it's a beautiful blue sky out there. I was extremely tempted. I was extremely tempted to pull my scope out and do a telescope live stream. Look at the moon, look at Jupiter. You know, nothing incredibly exciting or anything, but I'm sort of thinking about doing that in the next couple of days if it's clear. Do you think I should do that? I mean, it's you know, I mean, we'd be starting now. So I mean, you know, I could do this for a while outside. I would have to use this camera with this laptop outside, which is no big deal, as opposed to my smartphone, because eventually I would want to share this screen to show what I'm looking at through my camera. I don't have all of you seen this. This see, I did have a better webcam. I did, but I had to modify it a little bit. Hold on. So here's the back of the webcam, uh, which just looks, you know, like a normal webcam until I rotate it around, and you see that I've actually taken the, oh, hold on. So I've actually taken the front lens off and exposed. You see it? You see it way back there? That little rectangular shape. Can you see that? Let's see. See that rectangular out of focus thing? That's the actual CMOS CCD. And that's what captures the video for this webcam. Now this webcam, I think, I don't have the front of it anymore, but I think it was like a HP something 580, 520. I forget. But what I did is I took a 1.25 inch tube off of an eyepiece, and I gorilla glued it centered, right? Pretty centered, not bad. Centered on the CCD chip back there. Oh, there's a good view of it. And so it can no longer be a webcam because it doesn't focus, right? You have to put this on a telescope like that. And then I can plug this into my laptop, and I've got software on the laptop to be able to, you know, change the exposure time and the gain and the brightness and all that kind of stuff. And I can share the screen so you can see it. And any of you who are expressing interest in me doing that over the next, you know, like tomorrow night or the night after, I encourage you to watch my previous videos when I've done this before, and I put that in a separate playlist. So I forget exactly what the playlist name is. I can probably find that. Under playlists. I guess I called it Miss ADL live streams. So I've done this a couple times already. I think my first one was during that last lunar eclipse over North America, or, you know, over at least this hemisphere. And then I think I've done two others, maybe two others, maybe a few more than that, because I did do some sort of outside, not looking through the telescope, but while I was taking my calibration data, it just so happened, to coincide with 2 hours UTC. So it's like, okay, am I going to do my scientific work, or am I going to do my live stream? And it's like, you know what? I can combine those into one. So that's what I did on those. I think I've done at least a couple where we've looked at the moon and we've looked at Jupiter. So it's just it after our little hurricane blew through, it cleared up. I mean, cleared up. Amazing. The air, you know, uh, after 2 or 3 months, right, of this dry heat, it's like, things get a little cloudy, right? So, but after a rain, like what we just had, um, the air is just crystal clear and bluer than blue. It's just absolutely fantastic. No, Bobby, this is not my new webcam. This is what I use to put on to my telescope, so we can look at the moon and Jupiter and all that. No, I've got I think I've got 5 more days. 5 more days until it's been a week that I've had 100 or more subscribers, and it's at that point that I'm going to order the webcam. So yeah, any recommendations, I will happily take them. I am on an extremely tight budget because I'm a cheapskate. So I'm looking to not spend any more than about like 20 bucks or so. So it's not going to be a huge jump. 30 maximum. 30 is really overstepping my bounds. So yeah, but nothing cheap either, right? I mean, I don't. I'm sort of tired of this $5 camera here. So I am looking to upgrade a little bit. That's why 20, 25, maybe 30 bucks um, is really all I'm looking for. So if you have any kind of recommendations, that'll be great, because it looks like I'm going to be in the market. So, I mean, what do you think? Should I sort of plan on a telescope live stream tomorrow night? I mean, honestly, it's going to be the moon and it's going to be Jupiter. Um, and that's probably about it. Um, we can try. We can try to look at a couple other things. Um, yeah, there's some possibilities, maybe. So, what do you think? What do you think? Should I do that or not? I don't know. I don't know. Oh, Atta, you're being extremely generous. I think that at some point I probably will, because I think that there and I don't want this live stream to be any kind of advertisement or anything, but I am eventually going to be looking for supporters who will help me do my work, right? Which which um, which simply means you know getting some help paying all the bills, and my my needs, my slash our needs, are extremely simple. Um, we operate on an extremely low budget. Um, as it is, and happy that way. Maybe a little tiny bit more would come in handy, but pretty happy, right? Um, uh, but yes, I think eventually I probably will, because yeah, as I said, I would definitely like to do more astronomical research, um, publishable stuff. I mean, that is the quality that I am used to. It's the quality that I expect. And I actually have I have at least two papers that I'm working on. At least two, at least two. And yeah, I should. I mean, it's oftentimes hard to finish those kinds of things, especially if one has no deadline. So yeah, I mean, I would have to impose a deadline of some sort, that it's like, okay, work on it until this date, and then publish it. Um, Either self-publish or submit to one of the journals, and see what they do. But yes, I think eventually I will uh, be. You know, I I think one of my jobs is to say yes to many things. So yes, yeah. At least eventually, yeah. Um, uh, let's see. So, Bobby, what are you wondering that was so awesome? I don't know. I'm wondering the same thing. So yeah, yeah. Atta, I totally know that. Totally agree. Yeah, I I am not going to say no to most things I will say yes to. And yeah, I think that is definitely something that's going to pretty much happen automatically. That's not what I'm after. I'm after sharing the passion, right? Sharing the passion, and finding similar-minded people from around the world, right? Who share a similar passion, and sort of want to um, get out of what is currently out there, right? In terms of weekly shows, and every other day shows, and all of that, and more of the interview the expert shows, and chasing news and all of that. Yeah, I mean, there's a place for all of that, and the podcasts that um, do that, I shout out as often as I possibly can. Right, the weekly space hangout is absolutely fantastic. Fraser is amazing, right? But he's been doing this a really long time. And when you do things for a long time, you do become a master. It's the 10,000 hour rule. So Fraser is awesome. All of his co-hosts and guests are absolutely fantastic. Tony Darnell, he's great. His interviews and the people that he gets, for the most part, are really interesting, and things. I mean, he's got some kind of connection, right? Um, uh, and what it is, of course, is that he is sponsored by the American Astronautical Society, I think, and the American Astronomical Society. So I think they have a little bit of a hand in finding, well, thinking of and finding guests, because he usually has some pretty amazing guests. Um, there's Paul Matt Sutter, who is extremely awesome as well. He calls himself a cynic. Um, yeah, maybe he's sort of a cynic. Um, he's he's more of a cynic than he is a skeptic, I think, at this point, because he's sort of down, a little bit down. So, but that's great. It takes there is room for everyone, right? So yeah, I really like Paul Matt Sutter's um, stuff. I watch pretty much all of his posts. Gilles is in the house, and a huge shout out to Gilles doing his shortwave channel. I almost said software. You know, it's SW. um, his shortwave channel, and also he's got a number of computer channels, all on YouTube, and all absolutely fantastic. That I mean, when I started thinking about, well, here, let me put this another way. Okay, I was inspired by um, YouTubers like Gilles with that format. You know, just relaxed, laid back. Um, you know, this is just really me. The only difference, and Gilles, maybe you can also um, confirm this, right? Is that I usually don't talk this much. um, yeah, I'm definitely not like shy or anything, but I'm pretty quiet. I'm mostly interested in listening, um, because um, uh, usually what I hear is pretty interesting stuff, and so I just like to sit back and listen for the most part, especially if I'm in a crowd, maybe a little bit shy, but nothing debilitating, right? I just like to sit sit back. Oh, you're a big blabbermouth. Okay, yeah. See, I'm not. Um, One of the interesting things here is one of the cats who you've seen. She will uh, when I start this live stream, she will leave. Right? She knows that I'm about to start, so she will exit. Right? She'll want out. She'll get out of the way. Right? And literally 5 seconds after I stop, practically every live stream, she's howling at the door wanting in because it's like, oh, you're back. there was some there was some crazy man uh, talking, 1.7 words every second, and I just couldn't stand it. And but I'm glad that you're back now. So yeah, all right, but yeah, so I mean, that's the only real difference between um, uh, what you're getting is that you're just getting a little bit more talkative me, but the passion is always there, right? Um, um, yeah, I think um, uh, Gilles was definitely one of my inspirations to get this started. My other inspiration was Rick Beato. He's a former record producer and musician, amazing musician, and a music teacher. So he has a couple of YouTube channels. He's got a live stream channel, and then another channel where he does produced stuff. So like this is what he's doing like full time. He didn't want to be a producer anymore. He says he hates it. He hates producing records. Um, and so he's trying to to do the YouTube thing. He's got a book. He's trying to sell a book, and he accepts donations as well. And uh, and he too is very laid back. Seems to be himself, right? And that's sort of um, what I'm trying to do too. Yeah. Yeah. Well, some things just don't change, Jill, not at all. And that's okay. Some things don't change, most things do. In fact, the change itself changes. And I've talked about that before in previous live streams. It just goes on and on and on, right? Um, so let's share a passion. Since I got in a little bit late, I didn't have a chance to um, look at archive.org um, tonight yet. So let's go through it. Any new comments headed our way? I think there's a really great site. I'm trying to think of it, Totterbert, um, that lists the current comets. You know, let's go find out. I think I remember what it is, and it's sort of yeah, no, maybe this isn't it. Let's let's try anyway. I don't think this is it, but maybe it is. It's actually on that satellite observation site called Heavens Above. And this is probably not your best source of information, but I thought here's a comets list. So this table shows the brightest. I'm going to start my live stream on my YouTube channel here. Hold on, pause for a moment. There we go. So whoop, that's a that is a list. That's a list of the currently observable comets. So humans are good to about a brightness, which is just a magnitude, a visual magnitude of about 6. Okay, and in astronomy, magnitudes are reversed. So the larger the number, the fainter the object. And it isn't a linear thing; it's an exponential thing. So every difference of 1 magnitude is a factor of 2.5. So a 5th magnitude comet is 2.5 times brighter than a 6th magnitude comet. So as you can see, the faintest that we've got right now is 9th. Well, I'm sorry, the brightest is 9th magnitude. The faintest is 14th. That's a difference of 5 magnitudes. So right now, no, there are no bright comets. And well, you know, I've witnessed uh, migrate comets, and so I've actually checked that off of my list. I no longer have any strong interest in comets, unless they're exceptional, right? Because I mean, wow, I saw Comet Holmes when it burst. Um, the greatest comet I ever saw, and I can honestly call it a great comet. Like those ones that you see, the wood carvings with the comet across like the entire sky, right? It's like fire across the sky. Well, Comet Hyakutake in 1996 was a great comet. Great comet. Yeah, I'm not sure, Otto, which one you're talking about. Yeah, Hale Bop to me was not very great. It was very bright. It was very, very bright, but to me, it was not great. And this is totally biased, but um, uh, Comet Hale Bopp was a little bright comet, and what I'm looking for is a big bright comet. And Hyakutake was definitely the one. I still have a photograph of it up on my wall. Um, let's see, can I show you that without incriminating myself? Let's see. Oh yeah, I've got to not share. Yeah, you're not really going to be able to see this. So, let's not. But yeah, photographed by a good friend of mine, good astrophotographer, when it was up by the Big Dipper, and we went out sort of at its closest approach to Earth, and over the course of a half an hour, we could see definite motion, naked eye. So that sucker was close, and it was big. It was big. So I've seen great comets. At least I've seen one. So the path of comet CM1 looks like it's going to come close to us. I haven't heard of this one. Haven't heard that one at all. Should I look that name up? Yeah, Hale Bop was awesome, right? It was awesome. It just wasn't great. Yeah, yeah, totally, Tom. I totally agree. Yeah. Hopefully we haven't had a good comet in a long time. I mean, when was the last I mean, there was Holmes, and that was like what, oh 08, oh 07, something like that. It was soon after I moved out here. Um, but I don't really even remember. Yeah, I guess that was Naked Eye. Yeah, yeah, yeah. It was. But I'm trying to remember. Oh, there was Lovejoy. Lovejoy. Um, we definitely we definitely saw that, right? Naked Eye. I'm not remembering now. Anyway, so there's a list for what it's worth. You can they actually list um, a few other things too, right? They've got a little sky chart where the moon is, where the planets are, solar system chart. Let's take a look at that. Ooh, hey, you know what? I'm going to use that instead of uh, instead of um, uh, instead of the Stellarium one. I like it. So there's Earth, big blue marble there. Venus, right, is about as far to the left of the sun, that is east of the sun, as it's going to be. Oh, and Mercury is coming out too. Cool. And of course, Earth is catching up to Mars, which will be at opposition, wow, pretty soon, I think. And if you sort of draw the same line, see Earth is almost straight down from the sun. You can see that Jupiter is that away, and Saturn is also coming pretty close to opposition as well. Look at that. They mark Pluto down. It's not even a planet. Oh, here's nice too. Look at that. They're showing how far away it is from the sun, how far away it is from the Earth, and how fast it's moving. Well, that's pretty cool. You could set your time and date. That's very cool. I'm going to use that one instead. You know, this provides us with sort of an overhead view of the solar system. So it just, I mean, for me, it sort of puts me in a place, right? As opposed to just sort of floating around. You know, we can actually understand our relationships, right? So, for instance, right, if we look towards the sun, we're looking at all these background stars here, right? So, but if we look away from the sun, so say at midnight, we look straight up, then we're looking to all these stars way over here, right? So that's why we can only see certain constellations, certain times of the year, and certain at specific times of night, right? As the Earth revolves around the sun, right, it's going to be over here, and then our view is going to be all these background stars over here, right? Anyway, I think it's just a nice way to sort of put us in our place, and it's nice, you know, to keep track of when things like Mercury is going to be as far away from the sun as it can be. Cheers. Mm. Todderbert, Shoemaker Levy 9 was epic, and I was lucky enough to have seen it um, before the impact. So at a 61-inch telescope. So it was one of those nights where it was clear, but the seeing was terrible. And of course, I'd heard about Shoemaker Levy 9. Here, let me pop back to my ugly mug so you can so we can actually have a face to face here. Well, camera went funny. That's because I was messing with it before. That's right. Well, tilt. There we go. That'll do. So yeah, it was one of the nights at the 61-inch that was clear. So it's like, you know, I got to go, but the seeing was really bad. Yeah, yeah. I did a 2-year photometric survey of like 85 white dwarf stars, just measuring. I was just doing photometric measurements. So I was measuring in U, B, and V, and up at the 61-inch telescope on Mount Bigelow, just north of Tucson, and yeah, spent a lot of time up there, a lot of time. So this was one of those nights where it was clear, but the seeing was terrible, meaning that it was not photometric. And so I had a clear sky with nothing to do. And what 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 would somebody do if you didn't have any work to do? You were at a dark site. It was clear, and you just so happened to have a 61-inch telescope with an eyepiece. What would you do? Well, yeah. So yeah, I got to see Shoemaker Levy 9. It filled the, you know, the cigar shaped thing filled several fields of view, and yeah, I could pick out many of the individuals. So yeah, that was an amazing event, amazing event. So yeah, let's go over to arXiv and see if there's any interesting articles. Now this is something that I do every single day. arXiv, the new batch. Oh, I'm going all over the place. Sorry. The new batch usually comes out around 1 hour UTC every weekday. So Monday through Friday. And it comes out, you know, early, you know, 1 hour UTC. So that's an hour before this live stream. So to get myself in the mood, right, what I'll usually do is I'll read through the astrophysics articles. These are the newest, bleeding edge publications. So this in a certain sense the is what's happening right now, right? And I mean, you'll hear if you watch other um, live streams or podcasts or anything else, you'll hear about a lot of these because those folks are doing exactly the same thing. They're going onto this site and scanning the articles, right? So I have a little bit of advantage there because I'm doing a daily thing, and so I mean, for what it's worth, uh, I get the scoop on a lot of these things here, sort of the scoop. But let's see, formation of S0 galaxies through mergers. So S0 galaxies are technically spiral galaxies, but they have barely noticeable spiral arms at all. Maybe a little tiny bit, um, or they're disc shaped, but otherwise, not a lot of spiral arms. So those are sort of the S0. But yeah, let's move on here. The progeny of a cosmic titan, a massive multi-component proto-supercluster in formation at z equals 2.45. That's way out there in terms of distance and in terms of topic. Dwarf carbon stars are likely metal poor binaries, an unlikely host to carbon planets. Okay. Ability of exomoons around the Kepler transiting circumbinary planets. Wow. So yeah, these are binary star systems where they found planets. Can you imagine? I can't. I cannot. But here they're talking about the moons of those planets and how stable they are. Um, a number of transiting circumbinary planets. Although, let's see, let's zoom in on this a little bit. This is called the abstract. So it's just it's like an executive summary of the entire paper. So although currently not detected, exomoons could be orbiting some of these CBPs, and they might be suitable for harboring life. A necessary condition for the existence of such exomoons is their long-term dynamic stability. So yeah, they throw things into a bunch of models, these n-body models, and see what they come up with. That's pretty cool. But let's move on here. Binary pulsar distances and velocities from Gaia Data Release 2. Yeah, I mean that's pretty cool, I suppose. Let's see. More exoplanet stuff. Everybody's very excited about exoplanets, aren't they? It's just, I've said this uh uh I've said this a few times, about the discovery of life. I don't think I'm going to be too. I'm definitely not going to be surprised. I I understand the implications for some people. It's going to be a big deal, but I think for most, it's either going to be like so, or it's going to be like, well, yeah, I you know I knew that already, and I'm sort of in that camp where it's like, I understand that it's very cool, but I think it's very cool that there are trees and ants and things outside of my door here too. So it's not that big of a leap for me to think about life on other planets and moons. It just doesn't. I mean, I think it's going to be about as cool as it is here. And here is very cool. So, yeah. NGC 891. If you haven't seen NGC 891 in a telescope, please put that on your list, because 891 is very awesome. It's a mostly an edge-on um, galaxy. Again, it's over in Andromeda, the constellation of, and it's very awesome. I've recommended before, take a look at NGC 4565 as well. That one is epic. Through a telescope. Now, these things are not going to look like what you see in photographs, right? In a certain sense, they're going to be worse, and in a certain sense, they're going to be better. And the reason why they're going to be better is because you will know that those photons have been traveling for millions of years, and you are having the unique experience of those photons, right? And, you know, that's a connection. That's a physical connection to that object that you can't get with a photograph. You just can't. A photograph is essentially like a copy, right? It's not the actual thing. It's not the actual thing. So yeah, I encourage everyone, get out, look through some telescopes, look through some binoculars. Um, there are some absolutely fabulous things, and to be able to touch them and interact in that way is very special and very unique. And that's why, I will never get tired of looking, um, because it's just I know what it means to be doing that, and it has a lot of meaning, right? So here's a paper about the Large Binocular Telescope. I live right next to the LBT. I'm and well, right next to, in a sense that it's probably as the crow flies. I want to say 20 miles, 20 miles, 25 miles, something like that. I see it every day. It's this big, huge eyesore in the mountains, right on top of the mountains. It's a beautiful thing. So they're doing some Fizeau interferometry, and honestly, I forget exactly what Fizeau interferometry is. Man, that's my bad. I should know that. Probably some kind of high resolution imaging, because they're talking about um, the baseline of the LBT. So it uses two 8.4 meter mirrors. So it is a binocular. That's why it's called the Large Binocular Telescope. But from edge to edge, right? It's 22.7 meters across. So they can do all kinds of things with that. High resolution imaging. There's a relationship between how well you can resolve an object and how large your device is. So yeah, the bigger the telescope, the higher the resolution, or the better it is. But let's move on. Get a drink of this hydrogen hydroxide. Cheers. Best way, Bobby, to look through a telescope and get some almost some instant gratification is to find a local astronomy club and find out when their next star party is. That's what they call those star parties. And I've been to so many star parties with my scopes that I mean there's no way to count. I mean hundreds, probably thousands. During the apparition of Comet Halley, um, I estimate that 10,000 people looked through my telescope alone. So I mean pretty much every clear night, we would have some kind of event and be showing people Comet Halley, Comet Halley. I looked at Comet Halley every clear night from uh, um, June of 1985 to November of 1986. And I think for the next 3 years, I did not look at a comet. I was like, I am not looking at any more comets. I am sick of comets. In fact, I hate comets. So, yeah, find a local club and, um, you know, ask them to show you something that that isn't what everybody else is looking at. Because when we go to a star party, we sort of assume that people who are going there want to see the moon, right? They want to see Saturn, they want to see Jupiter, and anything else. If there's a bright comet or something, okay. But they don't even know to ask, right? Can we see a galaxy? Can we see a globular cluster? Can we see a binary star? And I can tell you with 99.5% certainty that if you ask anyone there who has a scope um, to show me a galaxy, if they know where a galaxy is, they will show you for sure. They will be delighted to not have to show the moon again, right? Now, I think the moon is awesome, but um, it's sort of like staring at your hand over and over and over again. It's like, okay, I recognize that, and it's like, yeah, that's my hand, yay, and that's sort of how I view the moon now. It's like, yeah, it's the moon. It's very cool. It's very, very cool. But I've looked at it so many trillions of times. It's like, okay, yeah, it's just the moon. But so yeah, definitely take a look at what they're showing, but then ask them, show me NGC 891, right? And they probably will if they can. Yeah, light pollution is a problem in the cities for sure, but usually, half-hour drive, you can be in some pretty good dark still. So that's not bad. Bobby, which observatory is it? Do you know? Ata, I'm going to, and I did this before. I did this in a previous live stream. You might look through my live stream list. Um, um, Search for telescope because I did a live stream quite a while ago, maybe a few months ago now, where I went to one of the telescope uh, online telescope sale things and just did some window shopping, right? Looked at a bunch of different kinds of scopes, looked at the price ranges, looked at the sizes, and I did make some recommendations. And probably what I should do is go through that again. I think it's about time. So I'm going to try to remember to do that over the next couple of days as well. I guess I have to decide if I'm going to do a live stream uh, outside of the scope or not in the next couple of days, because I want to be able to show you the moon, and the moon's out now. So uh, but yeah, so maybe I should do that again. Um, okay, huh? That's a very unusual place to have an observatory. Uh, yeah, um, yeah, and Uncle Bill brings up a great point, and that is go over to Deep Astronomy. Um, and I think if you go to like deepastronomy.space, I think that's his website, if I remember right. But you can also go to YouTube and just search for Deep Astronomy, and you'll find Tony's um, channel there. And yeah, he's done a bunch of shows on choosing scopes. My best advice, um, and here I'll since we're not getting too far with arXiv, although I am going to get through the rest of them. My best advice is to, if you can, go to some star parties, um, because there you'll be able to look through a bunch of different scopes, ask questions. I mean, amateur astronomers, like most amateurs, are really into what they're doing, right? They're really into it because they're doing it for fun, right? And so ask them things. How do they like this scope? What, tell me about it. And they'll tell you something, right? And then you can look through it, and you can, see if you like what you see. So that's my first piece of advice there. My second piece of advice is when it comes to purchasing. Um, uh, they say start low and go slow, and I'm going to give that same advice for telescopes. Um, uh, get something uh, that's not going to break the bank, um, and then be very patient. Be very patient, because you're going to have to figure out how to use the thing, right? Because I mean, really, what you don't want and what I don't want, I will cry. Okay, Pamela Gay cries when she has to program IRAF. Okay, I will cry if that telescope that you buy ends up in the closet collecting dust. If it does, okay, send it over here. I will give it a good home. And that's actually a little thing that I should mention. If you have a telescope that you're not using and would be willing to part with, I will take it. Send me an email, cosmiclettuce@gmail.com. I will take that scope off of your hands and put it to work. Yeah, put it to work. Uh, and yeah, start. A good place to start is binoculars, because it'll give you a little bit of magnification, and it'll give you a lot of aperture. Right? It's these devices are light buckets. Right? So the bigger the bucket, the more light you can gather, the fainter things you can see. So a, a good pair of 10 by 50s, awesome, very awesome. You will be delighted. You'll be delighted with that. Um, so yeah, those are my pieces of advice in terms of that. And probably what I should do is another live stream where we go through a bunch of different kinds of telescopes, and I'll talk about them and show them off, and note how expensive they are and all of that. Right. Um, Yeah, totally true, Uncle Bill. The best instrument is always the one you have with you. Yeah. Cool. So yeah. Try some scopes out, see what you like, see if you can find one on a good deal. a good deal. Otherwise, yeah, aim a little bit low, and get to know the sky and get to know the telescope a little bit, because there's a learning curve with all of those things. That's why with this live stream, it happens at 2 hours UTC every single day. You have to figure out what time that is for you, right? And that's sort of a jump into thinking like an astronomer, thinking about time. Time is really, really important to astronomy. Oh yeah, oh yeah. Yeah, Gilles, with even a halfway decent pair of binoculars, if you know where to look, if you know where to look, uh, in the middle of the city, you can see clusters of stars. You can see a couple of nebulae. Um, Lots of, well, binary stars. No, not really. Um, Planets, you're not going to be able to resolve really, really well. So even with binoculars in the middle of the city, you know, it's it's definitely not a place that you want to do any serious observing, right? But if you really need your fix, right, that's usually good enough. Cheers. I'll tell you, there are lots of things that you can do in astronomy that doesn't require anything but pretty good eyesight. You can observe satellites. You can observe meteors. You can observe some bright occultations, right? I mean, if there's a bright star that's going to be um, um, occulted, and that is blocked, the asteroid actually moves in front of the star. If it's a bright enough star, you can see that kind of that kind of thing. Um, you can watch the phases of the moon. You can watch the planets moving around the sun, and begin to understand what the relationships are there. So there's a lot of things that you can do without any instrumentation at all, except these, and so that's a great place to start. Is just get under the sky, get to know it, get to know it. Now, once you get a telescope, now there, I think a lot of telescopes. I don't think any cheap ones, though, not quite yet. But the more expensive telescopes have this go-to function, right? Which um, is a thing um, uh, where you can just align the telescope and then say, you know, go to M37 and it'll over, okay? And I find that putting, my amateur hat on, I find that very unsatisfactory because uh, I, I, I mean, half of my enjoyment is the hunt, is the hunt. So what I will do, and I mean, I've got a go-to on this scope, and when I'm doing professional work, yeah, I'm gonna I'm gonna I'm gonna use that because I want to get on the object, right? I don't want to have to look for it. But if I'm just looking, right, what I'm gonna do is I'm gonna pull out my charts, and these charts are charts of the sky, and it's going to be almost impossible to show you this, but you can see. I just so happened to turn on to the constellation of Orion there. And these show the positions of the stars and of nebulae and galaxies and clusters. There's some clusters up there, right? So these charts are simply that. They're maps of the sky. And so I can put this on, you know, the hood of my truck, and I can say, okay, what do I want to look at, right? And I pull out a chart, and it's like, oh, I want to find that. Okay. Well, then I have to say, okay, well, here's Capella, and okay, so where is Capella in the sky? There it is. There it is. So then, you know, I look for patterns, right? Star patterns, sometimes called constellations. Um, and I look at the patterns. And it's like, okay, this is where I want to end up. So I can actually use this technique called star hopping. Right, you go from one star to the next, and um, uh, you point your scope where you think the object should be, and blammo, there it is. So that's a lot more fun, especially because it's usually not that easy. So yeah, I greatly encourage not immediately using the go-to on scopes if you're learning the sky. Best thing in the world to do is to find them on your own. On your own. Yeah, 10 by 50s. Uh, you you can get a good deal on those. You might go to like a Goodwill or you know some kind of place like that, and you might find a pair. You might find a pair for you know a couple bucks. So and if not, those those kinds of binoculars, they are everywhere, and I'll bet you that you can find a pretty decent pair for 25 or 30 bucks these days. Yeah, maybe a little bit more. I don't know. So yeah, just be patient. Be patient. You know, learning the sky is takes time, takes time and patience, and you know it's easy to get frustrated because it's very overwhelming. But yeah, don't worry about that. Just enjoy, right? Just go wow. So let's get through the rest of arXiv and see if there's anything interesting here, because I haven't even looked at a paper today, and I'm feeling the withdrawal symptoms. Uh, I thought this was kind of interesting. I saw this somewhere else. This um, uh, CO hydrogenation. Thought that was kind of interesting. That's carbon monoxide, by the way. Gamma ray burst supernova associations, magnetic fields of gamma ray bursts, X-ray flares with polarization observations. Wow, that's pretty impressive. Tully-Fisher relation is a one of the many ways to measure distances. MHD, magnetohydrodynamic simulation of prominence eruption. That's pretty cool. So prominence is that event on the sun where you know the sun spews out visible material hundreds of thousands of miles. So photometric calibration for the Beijing Arizona Sky Survey and Mayall Z-band legacy survey. Present the photometric calibration of the Beijing Arizona Sky Survey. Well, where is the Beijing Arizona Sky Survey? Because it says Arizona. I live in Arizona, so I'm always yeah. There you go, Jill. That's perfect. I want to know where this Beijing Arizona Sky Survey is. Does it say anywhere? Photometric survey for the Beijing. The two surveys are performed in parallel. BAS is conducted in G and R. MZLS is in the Z band. Oh, okay, so okay, yeah, so BAS works at the 2.3 meter telescope on Kitt Peak. That's a telescope that I've worked at before as well. In fact, that's the first telescope I ever um, worked at, and I got to tell you, that is an awesome scope. We usually call it the 90-inch. It's the 90-inch scope. Uh, yeah, awesome. Okay. All right. I just wanted to know where that was. Introduction to Neutrino Astronomy. There you go. Yeah, Atta, pretty much any binoculars will do. Really, really. 10 by 50 is just sort of it's a pretty good magnification and a pretty good size. Reconstructing the universe in a computer. Physical understanding in the digital age. Oh yeah. Yeah. You'll be blown away if you know where to look, right? I mean, if you're just sort of scanning around, it's almost it's almost impossible to chance upon things. But if you know where to look, then it's you'll be really impressed. Yeah, yeah. Now with binoculars, you're not really going to be able to see like the moons of Jupiter or the rings of Saturn or anything like that. The moon will look spectacular, um, but you'll be able to see some galaxies, some clusters, some nebulae. So yeah, I mean it's a great start, great start. Um, so yeah, all you can do is give it a try. Um, I'm trying to think. I'm trying to think of a binocular object right now that you could see. Is where is well, let's just do this. I'm gonna pull up that sky chart from heavens above again. Let me see if I can give you a couple of recommendations on binocular objects you can see right now um, in your, late evening sky. So this is the sky, local time. Um, there's 2313. I want to do 2013. So let's see. Trying to think if there's anything binocular worthy. Well, I I'm certain that you'd be able to see if you looked at this star in the handle of the Big Dipper, which is going to be like directly overhead. If you look at this star, it's the Bend, right? It's the Bend star, that one. With a pair of binoculars, you can definitely see that it's two stars. I mean, with your naked eye, you can sort of see that too, but with binoculars, it's a little better. Looks like the sun is still up here. Oh, because I think, where do I have my location? Oh, haha, that's for Montreal. That's pretty funny. It remembered the last time we did this, and it was Gilles. That's pretty funny. That's funny. Okay, I'm gonna back way out, and oh, I'm gonna zoom in to approximately Arizona, southeastern Arizona, right? Oh, let me zoom out. I'm way down here in Cochise County, so I should be able to do that. Yeah, it'll find Sierra Vista, which is close enough to me. Okay, so now let's look at this. So this, of course, isn't going to be exactly your sky, but it's going to be really, really close. Yeah, so that's a little better. I mean, it's not changing much. So yeah, you definitely be able to see this binary star. So one of those stars' names is Mizar, and the other star's name is Alcor. And actually, each one of those, in fact, I think Mizar is like 5 stars, and Alcor I think is a binary as well. Definitely take a look at the moon, right? Take a look at the moon. Unfortunately, we're in galaxy land here. Um, Another thing that you can try to see, you're not going to see a lot of detail, right? But this is the constellation of Hercules, right? And here are these 4 stars, right? That sort of form a trapezoid, right? And this, if you're looking, this is going to be to your east, right? So if you're looking east, it's not going to be upright like this. It's going to be on its side, right? So this might be a little bit difficult, but just to let you know, okay? So if you take these 2 stars right here, right, and you draw a line between them, okay? If you go from this star along that line towards the other star about a third of the way, look with your binoculars right there, and what you'll probably see, um, you got to have a pretty dark sky, but what you probably will see is a little fuzzy looking star. Okay, it'll look like a star, sort of, but it'll be fuzzy, right? So you can look at all the other stars around it and say, okay, those are stars, but there's going to be one in there, and it's probably going to be pretty small and pretty faint, but it'll look sort of fuzzy. And that is the globular cluster called M13, and it's fantastic. So you might try that. Yeah, we're really pretty limited with binocular objects right now. Definitely take a look at the planets, right? Venus and Jupiter are up at sunset, and Saturn will be up soon after. So take a look. You're not going to see much. Not going to see much there. All right. Now, you guys have totally distracted me. I'm going to get through this, and then we're going to get out of here. Galactic LSST. I'm not really seeing anything that's grabbing me, and that's probably why I'm getting so distracted. New catalog of radio velocity standard stars from the apogee data. Pretty wild titles, I gotta say. Near-infrared observations of Olga, classical, and type 2 Cepheid variables in the Large Magellanic Cloud. Near-infrared. Multi-wavelength light curve analysis of Cepheid variables. So Cepheid variables are variable stars. They actually change in size, right? And they all share sort of this characteristic that there's a relationship between how often they vary in brightness and their intrinsic brightness. And so if we can measure how much they vary, we can make a pretty good guess as to how bright they are. And if we know how intrinsically bright they are, we can sort of guess as to how far away they are. And that opens up all kinds of possibilities in terms of understanding these objects. Quantifying spiral structure. I'm just not finding anything too interesting. I mean, it's all really, really cool. A lot of new papers, though. Holy moly. Is the beehive next to 44? I didn't realize that it was quite that close. Or quite that visible. Well, that's why, because it's the word Cancer was being blocked off by Venus. Yeah, look towards Venus with your binoculars. Take care, Gilles. Good night. Have a great one. Take a look towards Venus and sort of scan around, and you will see a cluster of stars there. Definitely, for sure. It's going to be really low on the horizon, but it'll be really, really easy to find because Venus is right there. So yeah, definitely take a look at that. That's going to be very, very cool to see. And I think it'll be easy. I think it'll be pretty easy. So yeah, Atta, definitely give that one a try. Just look towards Venus, sort of slowly scan around, and you'll see a collection of bright stars. It'll be pretty obvious. Yeah, very cool. All right, I'm going to get out of here. I've taken up way too much of your time, which I greatly appreciate. But yeah, I think it's time. I think it's time to close it out for today. So thanks everyone for coming on in. We'll do this again tomorrow, same time, 2 hours UTC, same place, maybe outside. Maybe outside. We'll see. We'll see. All right. Take care, everybody. Don't get dizzy. Don't get dizzy. This planet is spinning at 29.1 kilometers per second. So, hold on. Hold on. And I will see you again on that spin. Take care, everybody. Bye.